Hello all, welcome at Java City again. The agenda for today's video tutorial is to study remaining part of Java concurrency, that is starvation, pair lock, live lock, javaFx application thread and a background thread. So what is starvation? So starvation is a condition when number of threads are working on a common resource and due to assignment of some priority, some threads may not be allocated a required resource, the lock of required object. So the threads becomes in a wait state or a hold state. The task not gets executed. So this is a starvation condition. How we can avoid it? By using a fair lock mechanism. In this mechanism, the number of threads being allocated the required resource in a free flow manner, first in first out. So this ensures that each thread will be allocated the required object in a scheduled way. The next one is live lock. So as the name suggests, lock is live. It is very similar condition equal to deadlock, but here the threads being allocated the required resource even though the task assigned to particular thread will not be executed. What happens? The number of threads are getting the required object locked, but since their task is dependent on other task work completion, so all the threads or both the threads are in a wait state that the another thread will complete its task, and since the task is not get with that they are interdependent, that's why that condition becomes live lock. So we can just avoid this condition by changing the coding mechanism or avoiding the looping condition. The next one is javaFx application thread. So this is a way to make number of nodes based GUI application. In a GUI, Java based GUI application, the nodes work on a javaFx application thread. But if the number of any task assigned to javaFx application thread takes long time, likewise database fetching or data fetching from the internet takes long time, on that case the GUI becomes completely unresponsive. So another way to do this work, to assign the long time taking executing task execution work to background thread, and once the task is getting executed, the result may be browsed in a javaFx application thread. So this is a way to make rich GUI based application. So let's go ahead and try to understand all these concepts by suitable examples. So by completing all these concepts, I suppose the part of concurrency will be completed with the previous 4 tutorials and this 5th tutorials. So all concepts are covered in all these 5 tutorials. So let's go ahead and try to understand all these concepts. So stay tuned with Java City and let's go ahead. So let's try to understand starvation concept in a multi-threading environment. To understand this, let's create a brand new project, Maven project, by using an arch type quick start. Next, and what should be the name given? This should be starvation. This will be project name. Let me finish. And this, in this window, now the project will load required repositories from the local repository. It is doing so. Here in this concept, starvation, as the word suggests, it is scarce of some resources. What is the resource in multi-threading? Of course, resource is a certain object or a block of code which all threads are required to complete their task. So what happens in multi-threading environment? If number of tasks, number of threads are requiring a common resource, and if there is a priority assigned to a thread, so in that case the lock of the object may be given to a highest priority thread, and there may be a chance that the lowest priority thread may not get get the lock of object, and if the job is executing for a long time, on that case the lowest priority thread may not get the chance to execute their task. So this may be an starvation condition. So how we can avoid it? There is a class reentrant lock, just we have studied in a previous tutorial, and its object. So this reentrant lock will acquire a lock of object, and it will release for a while whenever it takes or it completes the one complete block of code. And in a meantime another thread which is waiting for the resource may get the lock, and again this will try for a lock, and it will easily acquire the lock till the completion of their whole task. So this is a way to manage number of threads in a multi-threading, so that the lowest priority thread may not be in a starvation condition. Here by the example we will understand. So here we will create a task subclass of runnable interface implementing class, and here we will create a run method which will do simple counting from 1 to 100, and this task will be done by number of threads. For understanding purpose we will take, it is taking long time. So here the class have been created, and we have taken a starvation thread color class, and this is main class. So let me delete this one, and we will create an inner class, and that will be class worker. This should be a static class. A static class worker implements runnable interface. Here we will implement override method run. In this class, before going ahead, let me create an object that each thread will take. So this will be static object, and this will be named as lock equal to new object. Let me take it public, no problem. Here this worker class will have a two fields. First we'll have a thread color. So private string color. Another will be private int, and this will be a count. Why we are taking here, we have to introduce a for loop. So many times we have implemented for loops. So this will have a consist of three small statements: initialization and condition for termination. So this will be equal to 100, and it will go up to, each time it will increment, and here we are taking this print out in the, we are formatting this output. First we are taking the color, after that concatenation operator, and here we have to formatting the string, and this count number is, there should be as this one, and let be this, and after that new line character, escape code for this one, and here respective fields we need to provide. So first one is %s, so string, and this will be a thread name, so thread dot current thread dot get name, and this will be count this plus plus. Okay, so this is now, since we are creating multi-threading, so here we are keeping this block of code in inside this synchronized block. So what we have done so far, we have created a worker class which implements runnable interface, and here we have created a static object lock, and that will be taken by all threads whenever the thread name, this block of code will execute, and this is complete 1 to 100 counting. Now let me create number of threads in a main class. So let me create object of thread. So this will be thread T1. This is equal to new thread. Now this new worker, and here we have to thread color dot red. This is for first thread, and now we are assigning the printable name. So this will be priority 10. Okay, here we have to we haven't created constructor perhaps in this worker class. Yes, of course. So we have to create a constructor for this one before. So create constructor, and then we will take only one. So this thread, now let we copy it and create 5 more threads, 1 2 3 4 and 5. Let me give first change the name of object. So this will be T3, and this will be T4, this will be T5, and here the name color should be changed. So this will be, let me take blue, let me take this color green, let me take this color cyan. Why we are taking color? Just to differentiate after assigning priority which thread is given chance to execute their task, as it will be difficult. And now let me change the name appearing and a print. This will be priority 6, this will be priority 4, and this will be lowest priority name, and after that we will provide priority 2. So let me provide a priority 2. So T1 dot set priority, and this should be given 10. This is the actual priority we are defining. Let me define the priority to other 1 2 3 4 5. Let me change the name. This is T2, and here we have provide the priority to 8. As we have given the name, this should be given the object name 3 T3, and this is the priority for T3 object, this is the priority for T4 object of thread, this is the priority 4, and this is the priority for T5 object, and the priority is 2. Now last step, T1 dot start. So here 5 more threads, copy it, 1 2 3 4 5, and let me start all thread. So this is T2, T3, T4, T5. So friends, what we have done so far, just to study starvation, here we have created a worker class that implements runnable. So it has a default method run, and here is a for loop. This thread will start counting 1 to 100, and here we have created a synchronized lock. So this lock is a static object, and we have synchronized this just to ensure that this block of code will be executed. After that, the lock will be released to another one, and let us see what happens. And here this thread, 5 threads have been created, and this will be given name to appear. And here we have system.out.format. This percentage string will format this, and this will provide a name, and after that it will provide a count as per this one. So this will be a string which will appear in a color this, and here first it will, the string name will be there, and after that this will be the int variable this count, and once it will be given the value, after that this will be incremented. So let me run it and see what happens. What is the effect of priority assignment to a thread? Whether the priority is assigned to thread to provide lock of object. Before going ahead, let me first change this view mode to window, and let me resize it, changing its height to, so that the result is visible in a good manner. So you can see what is happened. This is priority 2, priority 4, and priority 6, and priority 10 at top. Let me run it again. You can see the same result, priority 2 at last and priority 10 is first. Let me see again, priority 2 at last and priority 10 at top. So what is happening, and why? If this priority 10 thread is doing a long task, and if each time this priority has been given 10 to this thread, so priority 2 thread will be executed at last. And it happens if this thread is doing lots of work, so the lock of object may not be provided to lowest priority thread. So how we can avoid it? This may be avoided by providing a fair lock mechanism. So fair lock means this ensures the lock of the thread, lock of the object will be provided in a FIFO manner, first in first out. So each time the thread requires object will be given the order in which it is requiring. It is in wait state, and we will take object, and the required code will be logged by the reintrant lock. Once it will be executed, it will be provided to another. To whom it will be provided will be decided by the fair lock mechanism. So before going ahead, let me first change this object of reintrant lock, and this is reintrant. This is a new reintrant. This is a reintrant lock, and here we don't need to provide this. After first we will study without priority, and here we have to assign this lock dot method lock. It will lock this one, and after that we have to try and finally block, and this will be deleted. and here this also be deleted, and this block of code will be kept inside this one try back block, and here it should be given finally, and this lock object must be unlocked even though the. So what we have done, we have used a fair lock to avoid this starvation condition just seen before by assigning the priority, the lowest priority thread to have it is coming at last always, and if there may be a chance that this thread may not be given a lock, so we have simply using a fair lock, and here the this reentrant object lock will be given a priority true. You can see this public reentrant lock boolean fair creates an instance of reentrant lock with the given fairness policy. Fair true if this lock should use a fair ordering policy. So what it means, if we are providing true, it means it will use a fair lock mechanism, and it will assign the lock of object required this lock object lock to each thread once it will complete and based on FIFO. So as we are starting this T2, 3 and this one, it will provide the lock. Of course, the scheduling is complete matter of JVM, but still the thread started first will be executed first. This is an established concept until JVM not feels any hurdle in execution. So let me go ahead and try to run and see the what happens, the behavior of this code, how we can avoid the starvation. You can see this is the way, and execution in this way. So this is how nice it is, because each time the thread is executing its task, this 108642 and this is 108642, it is completing one line of code, and after that clock is released, it's given to the next, and again the FIFO, the queue is repeating itself till the task is completed. And if we suppose assigning a priority, then what, there is no meaning of assigning a fair, because priority and fair there is a contradictory. Even though what happens, let me see, you can see like this, the priority is dominating, sometimes the fair lock is dominating. So this is a way, it is simply random behavior of this one. So we don't need to provide fair priority if the thread is, it completely works on this principle. So let me change this starting time. So this will be the lowest, or the thread named as priority 2 is started first, and so let us see the fair, it is starting first, it means it will given the lock first. So let me see the result, and you can see what is happening here. This is 8, 6, 10 and 2, so it is given at 6. So this is all about behavior, but this is by this fair lock mechanism the starvation never comes, because once the block of a single line of code will be allocated and in between the lock is released, it will simply be provided to the another one waiting for the lock, and this cycle will repeat till all the threads are execute their work. And here the all processes, the thread of all process will be in continuation, so there will not be any chance of starvation condition. So this is a concept of starvation. So let's go ahead and try to understand the live log. To understand live log demo, so let me start next new project, live log demo. Here I am again reiterating what live lock is. Lock is live, it means lock has been given but still the process is not completing. Why it is happening so? Because the resource is getting allocated to each thread, but since each thread is waiting to complete the task of another thread, so it is not executing its task now and it is on hold. Another thread which is still waiting for completing a task of previous thread and it is on hold, so it is also not executing. So both the thread are waiting for completion of their task. That's why the process not going ahead, and still the situation is on lock. This is called live lock. How we can avoid it? We will simply change by changing the coding pattern or looking the situation why the another thread is in a wait state because of the first thread, and by re-inspecting the thread we can simply avoid this situation. So to understanding this live lock, we have created another project, live lock, and here in a source main we have to change the name of this one as live lock. So starting this, first we are creating a class shared resource. This is a resource. Sorry. This is a class, and this class will take a resource of worker. This is a worker having work method. So here it is field private worker let me create a constructor. This should be below than this. This may be given as a name as owner. It appears this one. Now let me give a getter and setter, and this should be setter of this. This should be synchronized. Why it should? Because both the thread will call this setting there. Later we will understand. And if any in between the lock is given to another one, this may create a problem. So let me program. So this is somehow shared resource and worker. Here in this worker, what there is a field of string name, the name of worker, and another one is boolean, and this is active always equal to true. Now let me make a constructor, and this will only be we have to take both one. So constructor is taking both the parameter. Now getter and setter for both the fields. Now worker class has been assigned. So let me go in a main method, and here create a object of shared resource, and this should be first we are creating object of final worker 1 is new worker, and the name should be worker 1, and here the priority should be active. Yes, it is active. Okay, and this is, as the name suggests, what we are understanding, live log. So both the threads are active, both the threads have been allocated the log of required resource, but they are still in a hold state. Why so? We are going to understand. So this thread is this one, new worker, the name is this may be worker 2, the object, and both the name I have taken as same. Don't worry about this one. Now let me again create a object of shared resource. This may be given as name as shared resource, as new shared resource, and this should be given with worker suppose 1. Let me start this one. Okay, now let me create 2 threads, new thread, new runnable. This is a run method, and here we are calling object 1 worker 1 dot, here we have, okay, we forgot to create worker method, worker work method, so most important one. So let me give a work, so public void work, so what it is going to do, it is simply working on a calling. If one worker is calling, so it is transferring the resource to another worker. So worker, and this maybe is other worker. So let me check it. While active, let me check the condition. If so let me first check it. If shared resource dot get owner not equal to this, then what will happen? We have to wait for some second, pretending that the object will be allocated to this object. So wait for few seconds. So here it is 10, and let me make it inside this catch block, interrupted exception E, and after that this should be continue. Here, and if other worker active, what will happen? What we have to do? If other worker is active, we have to simply transfer get name give resource to other worker dot get name. After this, we have to make active equal to false. This should be at last. So it should not be here, otherwise it will be shared. And this, if both the things are happening, then on that case we have to come out this while loop, and after getting out this while, get name working on common resource now active. Before, to avoid going again in a loop, this should be made false, and shared resource dot set honor other worker. So I think the things have been over and we have already done so far. So we have created object of two threads, two worker, and this should be given worker 1, sorry, this should be given shared resource, comma, this is worker 2. Okay, and now this should be given dot start. Let me again make another thread, and here worker 2 dot work, and this should be given as worker 1, and this should be given as dot start. So I think the things have been over. We have created what we have done so far, and we are trying to understand the live log. In this case, the threads have been provided the resource in a arranged manner. There is no waiting of a resource, but still they are working on a shared resource. It means the thread 1 has started its task, thread 2 had started its task, but since they both are using the shared resource, they are waiting for completion of the task of each thread, and in between they are in a hold state. So here is a worker class. You can understand this worker class. This worker has a name and its status as a boolean active, and we have a very important work method. This is taking parameter as a shared resource and a worker who is calling this method. This object is calling this method, and it is passing the another worker to whom with it is sharing the resource. If suppose this object is active, so we are taking the shared resource of honor. If it is this object, then there is no problem, it will simply go ahead. If it is not this, it will go and try to wait. This is pretending that it is waiting for getting a shared resource, and it will continue skip this. After that, we are trying to fetching that whether the other thread is active or not, because both have started their work. If it is active, then we are trying to get that calling thread will transfer the resource to other thread, and simply shared resource will be transferred to other thread. Okay, and you can see after the completion of this if block, it will go out the while loop, and after completion of a task, it should give in a console that both are working in a common resource to understanding the task has been completed. So what we will see that this line is not getting printed in a console, they are entangled in this loop. Even they both are active and both are working, they are just simply trying to wait, and after at last we will simply try to hand over this resource to other thread. So let me try to run this, and this loop will go on. If it is owned by this object, it will skip and come out over here. It will check other worker is active, it will transfer the resource to another one, and once it will complete, okay, we have to check this is the condition which we want to try. Okay, so again it will shift the, and you will see the situation is, and let's see. Okay, the worker method should be synchronized because both the threads are simultaneously calling this method, and if in between a worker method is work block or work method is allocated to any thread, the execution will not get complete. So it should be ensured that the execution of a work method need to complete before allocating to another thread. So this should be synchronized and all the things have been completed. So let me run it, and we will see what is happening. It should demonstrate the live log. Okay, you can see worker 2 give the resource to worker 1, worker 1 will resource to worker 2. So both the threads are trying to hand over the resource to another thread in order to complete their task, so that they itself can complete their task. It is a loop condition. Although the block or a block of code have been allocated to both the thread, but still there is no progress in a task execution. So this is a live lock condition, and how we can avoid it, let me try to understand. We need to terminate this loop condition. If other work is active, if it is true, then it will hand over to next one. It will not skip, otherwise it will go ahead in execution. It will again not check the condition. So first this will complete, and again if this false will be there, both the process will definitely get complete. So let me run it again. You can see worker give resource to worker 2 and worker 1 working on common resource, worker 2 working on common resource. So this is the end of this one. This is if it is working worker 1, so working on a common resource, you can see this is a complete of task. So this is a live log condition, and how we are coming over this live log condition is getting or analyzing the code. There should not be loop condition between before execution or completion of a task. No thread should hand over the resource to other thread. So both the threads are in hold condition. So that's why this situation is little bit cumbersome. So let me try to go ahead and try to understand some more concept. Try to understand javaFx application thread and how it works, how the thread interference works. So to understand this, let's start with a brand new project, javaFx project. So this is, let me go ahead next, and this is javaFx thread demo. So this is a project. You can see once we have created project in Explorer, 3 files have been created. You may see this. Now we have to create a, since this is Java 11, so in Java 11 there is a fresh and a separate module for javaFx, and for creating javaFx you need to import the module info in a class path. Whether the things you can see, so this is a required libraries, and this is javaFx base. Same need to, we have to this javaFx dot controls requires javaFx graphics requires javaFx XML, and now opens sample. Okay, the things have been streamlined now. What we did here, we have created a new project and we have browsed the module setting, and we have imported the required libraries in a class path. Also, since this is a Java 11, so here javaFx is provided in a separate module. So here we have given module.-info.java, and this file need to be configured for running a project. So this all we have done. Now this is a sample, and here you can see this is a controller. So this is MVC concept, you may say. This is model view controller. This is view and this is a controller, and this all things need to, so let me, this is a grid pane. So what we are going to do here to understand the javaFx concept, we are going to create a pane, that is grid pane, and this grid pane will have a controller and all kind of programming will be done. The project will start from the main file here, and this extends to application. This is a method, start method. Also there is a init, stop, and life cycle of a javaFx. So later we will study in detail in javaFx separate video tutorial. So here we are we are trying to understand concurrency, and this javaFx application thread, it's a single thread. Whenever we are interacting with the nodes or any kind of button or any GUI element, this will be only done, or the things will be coordinated in a Java application thread, main thread. What happens if long execution we are doing in this thread? So on that case, the things or the rest of the GUI will be unresponsive, and this is the main drawback of this one. Although being a single thread, the thread interference is not provided here, not happens in this one. So let me go ahead and try to create a button. We want to click a button, and once button will be clicked, we will want to try to fetch some strings, name of strings in a list view, and we are pretending that once we are clicking in a button, the data is fetched from a data source. For that we will halt a thread for a very 1 second or 2 seconds, and we will see during this time the GUI is completely unresponsive, and for make it responsive and to avoid it, we have to do this fetching work in a background thread. And once the data is fetched by the background thread, the data from the thread need to be taken in a main application thread. So later we will do. So first we take a button and a list view. Here it is, list view. Okay, so two items we have taken. Now let me first give the fx id. So this is show button. Let me give the column and row index in a grid pane. So this is row index 0 and column index 0. This is a list view. Let me give the fx id. What is fx id? This id is used to communicate for internal communication between controller and sample.fxml file. So this basically the node is identified by the controller by its id. So here it is fx id. What we have to do, my list view. Let me give the column index, and this should be column index 0, and let me take a row index 1. So let me first run it and see what happens. A grid pane should appear in our screen, and there should be a button, and there should be a list view. So you can see this is a button and this is a list view. Let me enlarge the size of this main stage and button 2. So let me give the text in a button. So this is a button. So here we can write text, and that should be given as show, and let me give a method, this on action method. This is hash handle show button. This is the method which will be programmed to tackle this button functioning. Okay, so let me first create this field in a controller. This list view need to be created in a controller, and this method need to be created in controller. So you can see here, let me annotate with fxml to clearly visualize the controller that this is fxml node, and also we have to identify this method too. So we have created a handle show button. There is no need of this action event. Okay, so we have done so far. We have created a button. So what we are doing in this, once we will click a button, we will try to fetch some data in a list view. So let me create a observable list. So this is observable list, and this should be of type string, and that will be equal to fx collection dot, this may be given as employee. Okay, empo employee. What we are doing here, let me create a for loop. And this for loop just to iterate through the list and in each iteration it will give so many times we have created a for loop. So again of the same type, this is int I is equal to 0 starting from first semicolon condition I less than 6, or how many items are there? 1 2 3 4 5 6 6 items, and this should be in each iteration it will incremented by 1. And here what we are going to do, we are pretending that it is fetching the data from database. So in each iteration we are, this should be handle the exception, so it should be in a method signature. Since for the demo purpose we are taking thread.sleep method, so we have already taken a exception handling in a method, but it is recommended that always the interruption method need to be taken in try catch block. So this thread.sleep, now what we are doing to doing here, we have to this should be taken. Now at last of this one we have to iterate my list view dot set items employee. Okay, so let me run it and try to understand what is happening. This is an observable list which is containing 6 items of type string, and here for loop we have taken, and each iteration we have given a 1 second sleep time, and in this time the thread will sleep, and during this whole execution of this complete task, but in a main thread the list will be populated with these items, and during this you will see the complete GUI is unresponsive, and this is completely undesirable. Let me run it and see what happens. It should take around 6 seconds, as we have, you can see now it will be clicked. Let me expand this first and let me click this. So it should take 6 seconds, you may say, and during this second let me again run it, and during this process you will see once I will click, it will start the main thread and it will start the execution, and it will go in a 6 second work. During this 6 second time, this show button will be completely unresponsive. And how to check this? Before clicking this, let me make a print ln statement. This will be clicked. Okay, so let me run it, and once we will click, this is a console, you will see. Okay, now see, once I will click this show button, in a first click this will respond clicked, and the process will start, and during this 6 seconds we will again click, the GUI will be unresponsive. You can see this one, and now you will see this is, I am again completely pressing, nothing is happening. You can see now it is clicked, but in during the 6 second the main thread was busy in fetching the data and via this system. But you can see now after completion of 6 seconds this it clicked. Now the GUI is responsive. So this is completely undesirable, and the main thread is busy in a one work, but after that if we want to do any other work it will simply not do. So what we can do here to avoid this? The solution is do the work in a background thread, and once the work is completed, just try to browse the completion of the result of the work in a main thread for populating in a GUI. So let's go ahead and try to do this complete process in a different way by creating a task. So let me create a task. So to do this all thing by another way, let me create an initialize method. So this is public void initialize, this is initialize method, and create a task of type observable list of type string. This observable list will be of type string, and that will be named as object name is task. So let me create task, this task equal to new task, and this will automatically have a call method. Here let me create a first observable list, so this observable list of type string, and that will be the object name is employee. What we are doing here, we are trying to fetch the employee list of type string in a list view, and we are doing all this in a javaFx application thread. Now just we seen that if we are doing all the things in javaFx application thread, the list view is populated, and if it is taking some time while fetching data from the database, during this time the GUI is completely unresponsive, and this is undesirable. To avoid this, the work which is required need to be done in a background thread, and for doing so we are creating a new task, and this way we will try to make the GUI responsive during the fetching of a data from a database or some other function. So here we are pretending to fetch the data from the database. For that we are taking an observable list, and this observable list object is employee. Here the employee will be initialized as fx collections dot observable list. Now let me create a string array that will consist of list of string array, and that is given as a names, object name is string array, object name is names, is equal to new directly we initialize with the data provided here. So this is the data, we will just copy it inside this array. Now this has been this array has been initialized with the 6 names 1 2 3 4 5 6. Okay, and let me delete because already we have created this. Now this is a task. So what we have to return here, let me create a for loop for iterating through the array. So many times we have already taken for loop. So here we have to take a int I equal to 0. Why we are taking 0? Because array index starts from 0. It will proceed up to array length names dot length. You should always remember, while talking or while taking iteration through an array, this should be taken less than, not equal to. If you will take equal to, because the length is not start, length is here, the length is 6. So if we will start from 0, it should go up to 5, so that it will cover 6. Otherwise there will be an exception. What will be? Out of bound exception. So let's go ahead, and this will be incremented by 1. What we are going to do here, in each iteration, this employee will be added, and what will be added? Names and element I. Okay, what next? After the completion of this one, this for loop, we will try to populate this list view with this one, employee observable list, and now return what? Employee. So this will be return y. Now here you can see this is a method, and here we have to employ a semicolon. So this we have created a task, and that task, the name is, so here in a handle but show button method, what we have to do, we have to create a new thread, and that should be given as a name task and dot start. Now what will happen? The thread will start, and thread have a task, and task will do all the things, and this interaction of GUI and this thread result will be done by a method. What it is, it is provided platform dot run letter, and here we have to create a new runnable, and that will have a default method run, and this will do what? It will populate the list view. So what we have done here, we have created a thread. For creation a thread, we need a task. So we have created a task object that have a by default call method, and that call method will do all the things required. It will have a observable list. It will return observable list. For pretending that we are fetching the data from a database, we are doing so. We have taken an array of 6 string items, and each iteration we have to make that some time is spending by a thread. So we have to call a sleep method, and that will be of 1 second. Okay, so this whole programming has been done. Each time it will sleep for 1 second. After woke up, it will add the element of array in a employee observable list. Completing the task, it will return the employee observable list. And for interaction of a GUI FX application thread and a created separate background thread, we have taken a platform.run letter method, and this will create a new runnable, and it will populate the returned employee list. And here in a show button method, we have created new thread, and that will take a task. Later we will try to see how the progress is going on. We will create a progress bar. Here in sample I have just created a progress bar, but later we will go ahead with this one. So let me run it and try to understand what is happening. I hope the things will go as we desire. So here the things is happening. Let me click it. It should spend 6 seconds, and you can see Now after completion of 6 seconds, this list of strings have been populated in a list view. Let me again run it. Let me close it and run it, and we will see during this time this will be interactive. So once we will click this, it will start the work, and it will do in background. Once after completion of work, the platform.run letter method will fetch the data from the background thread, and during this time too GUI will be responsive. So you can see, and how we will check it. Let me close it, and here we will have a method in a controller. This is in a console. We will just clicked again. So once we will click each, although the thread will start again and again, but this will be responsive. So just for checking purpose whether the GUI is responsive or not, we are again clicking it and running it. We will try to click, and we will see in a console whether the thing is happening or not. So here we have just, I will click, it will print out, just click again and start the thread. And after that, during this 6 seconds, if suppose we are again clicking this, it will again respond. So this is, you can see, just clicked again, and you can see just clicked again 2 times 2, and this has been opened. Now again the thread, both the threads, each time thread has been started, and it will again start, but it is responsive. So this is the best way of doing FX GUI based programming. All kind of work which takes time need to be done in a background thread, and once it is completed, it will be acknowledged to FX application thread by a method platform.run letter. So let me do another way of this, smart way of doing this. What we will do, we will try to understand data binding. So as the name suggests, data binding mean to say the GUI based application will understand, or the progress in a GUI application will be tracked, the things happening in a background, and once it will be completed, it will be worked up and the result will be appeared in a screen. So in a games, in a GUI based games and animation based programming, this gives quite important, so that the person who is working on a GUI may get aware that the things happening in a background, and soon it will be completed. So for doing so, we have to employ a progress bar here, this progress bar, and we have to assign an ID, and let be whether the ID is, yes, it is ID. Now what we will do, we will check the progress of this doing all the things in a background in a progress bar, and once it will be completed, it will be populated. So what we will do, we will update progress of task, update progress method. So here we have to employ update progress method, and here what it is, I plus 1. Why to so? Because it is starting from 0. So 0 is not taken as an index because the 6 item is there. The progress need to be taken in an int value from starting from 1. So here I plus 1 and go up to 6. So this, and now in a progress bar, we have to employ how we can see all the things happening in the background by data binding. So just after completion of this task, let me create a data binding. So first what we have to do, we want progress bar. So my progress bar dot progress property dot bind, and what should be task dot value property. Sorry, task dot progress property. So my progress bar, progress is binded with the task dot progress property. Another way is my list view dot items property dot bind task dot value property. So you can see now the list view, there is no need of this one because we have binded. So let me comment it out. This program that run letter method. So let me comment this, and now the thing should go on as it is. So once we will click, it will be responsive, and it is a much smart way of doing this. Let me run it. We will do some more thing, and we will enhance a better way of programming by employing data binding in our GUI. So here we are just going to click. Let me see where is the progress bar. Okay, this is a progress bar. So let me click it. Okay, you can see the progress in a progress bar is appearing. 6 times it will go, and after completion of 6 seconds it is appearing. Okay, we haven't made, so it will do it will not reset. So let me do some more thing. What we will do, we have to, what next we want that the progress bar, you can see this one, before clicking the button the progress bar is appearing like this. You can see this is not a good way. So what we can do, as soon as we are clicking this progress bar need to start, and once the task is completed, this should be not visible in a screen. So what we have to do, let me do something for this. So here my my progress bar dot visible property, and that should be dot bind task dot running property. So it will be visible as soon as the task will be running, and as soon as it will be end up, it will be disappearing. Okay, before going ahead, let me go in a main program and let me increase the size of our scene to 500, so that by default it will. So let me run it again, and you will see there is no progress bar because we haven't clicked yet. As soon as we will click it, it will start running. You can see now the progress bar is appearing and it is showing, and once it will be complete, it will be okay. Now the thing says, because this is a better way of programming. Why so? Because a person who is working who is in front of the screen will know that the things is happening in a background, and GUI is still responsive. Okay, so not what we can do more, something more. If we are suppose clicking the button and the process is going on in background, and suppose again we are clicking wrongly or intentionally, that our GUI is not performing well. So what we have to do, we have to make a certain arrangement that suppose we want to click, if we are clicking again and again the button, it should restart the process. So what we can do here, we have to program in a button what, let me really delete this because no need of this one. Suppose if, okay, before going ahead, first we try to understand the service class. So service class docs, let me go ahead, and here service class Java docs, you will see in a concurrent there is a service class and have certain method. This service class, service objects provide the client view a web service. So in a GUI based application or in a web based application where front end is working, this method will create a task. Now by default method create task, and here in this task you will see this service will work as a task creator, and automatically once the service is started, it will create task and it will do as it is. So this need to be studied before going ahead. So let me use this service class, and this service class either directly can be called or by using a subclass of this one. So let me create a subclass of a service class, and that will let the class name is employee. Okay, let me create this class employee, and this extends what? Service. This service will be of type what? It will be of type observable list. This is observable list, and this observable list will be of type string. Now it is prompting to implement method. So here we have to, this create task is a by default method. This is because this is a override method, or this is method of superclass service, and this will return a task. And now you will see here this will be created by low. So let me copy all the things. So here this, from here we will copy return new task, and this till now up to here. So let me copy it. Let me delete this, and in employee class let me return this new task. Okay, and for the purpose of this one, let me create an observable list here in this employee class. This observable list employee, here you can create just inside this class. Now update progress, and here this task create new, this will return, this will have a call method, and it will return a employee. So this return employee. So after completion of this one, this should like this, and this will go up to task. So again one more curly bracket need to be here, and this should be ended up with this one. Okay, here it is, and again one more thing is there. Okay, so this will return, so this service will return an employee. This will create a task, and it will return a task, and this task will return a observable list employee. Okay, now here in a controller, what we have to do, just we have to create below this controller the object of this employee. So employee service is equal to new employee. Okay, we have created an object of this one, and let me replace this task with employee service. This employee service, this employee service, and this is employee service again. So what we have done so far, we have created a service and subclass of service class employee, and we have created an object of this employee class employee service, and this do all the things the service required related with the employee an observable list. We have created a task inside this service method. By default method create task, and that create task will do all the things. It will do fetching of a data from the database and will return an observable list that will be available with object. And here the progress bar and a list view and my progress bar visible property, all the things have been binded with the object of this service class. And here instead of doing this one, we have to just start the service. So let me start the service. So employee service dot start. So this method, so once we will click, it will start the service, and a service in a background do all the things. And by binding the data, and this initialize method will initially bind whatever the work is done by this platform.runLetter method will be done smartly by binding the data, and it will automatically continuously will show the progress. So let me run it and see what is happening. There is some problem in employee class, so let me run it and see what is happening. Okay, this is creating a problem. Okay, because already we have. Okay, so let me run it and try to do whether the things is going in an intended way or not. And this is a smart way by using a service class in a multi-threading with GUI application. I suppose it is better. So you can see the things are appearing as it is, except the programming in the background have been changed. So let me click it, and you can see the progress is appearing in a progress bar, and after completion of this progress the data is fetched. Now let me click it, this it is giving an alarm. So let me make some arrangement for doing so this one. So what we will do here, in a button clicking, in a controller, we have to check the service state. So let me do this one. So if what we will see, if employee service have three, you can see is if the employee service starting its work, it will be on the state ready. So what is happening, once we will click the button, if the service is already been completed or if it is ready. So if it is ready, it should start the service, and if already succeeded, after clicking the button we have to reset it, just it. So let me get state dot get state dot equals what, the state dot succeeded. So on that case, what we have to do, if already succeeded, we have to employee service dot reset, and once after reset we have to start again, dot start. And if else, if the employee service dot get state dot equals state dot ready, on that case what we have to do, just we have to start the service, employee service dot start. So what we have done so far, we have just made an arrangement that if suppose we are again clicking the button, this should not give in any kind of exception, else it should be handled. So if already the things have been completed, we again want to see this one, we will click and it will reset and restart the service. And if already if first time we are clicking, it will restart the service. So let me run this, and I think why it is giving the controller alarm, there is a okay expected, where it is expected. Okay, semicolon, A statement semicolon simply declares that the statement has been completed. Java will assumes that the statement is completed. So we have just why this alarm is coming, why this exception is coming there. So okay, this is working properly, but still there is a exception. Why so? Let me check it. Can only start a service in ready state, was in state scheduled. This okay, this has been repeated. This is the problem. Okay, so let me run it again. I think this time there should not be any exception. You can see it has the service has started and is working in a background, and once it is completed the progress bar is disappearing. And let me again click this. Okay, so this is again doing the same things because the service has been reset and it is started again. So you can see this one. Okay, so this is the way of handling or doing the work with the GUI. So I think some important things we have covered in this tutorial. So we have done something about javaFx application thread, and we have tried to understand how the things are happening in a background and how we can coordinate with the application main thread in javaFx, and how the exceptions can be handled. So this is all things we have taken in this tutorial. So I hope by doing practice it will make some more conceptual knowledge about the javaFx application thread. So already this video is quite long, so I hope this multi-threading part of a Java has been completed, although in a brief, but has been completed. In a next video we will take some more topics about the Java. Till then, stay tuned with Java City and keep practicing. I hope the things will be better after practicing. So bye for now. Wait for next tutorial.